Okay, now I went to making up a problem, and I didn't talk about what I was thinking about, okay? We're not quite done here, okay? Now, we talked about it last time, that partial with respect to x of the partial of f with respect to y equals the partial with respect to y of the partial of f with respect to x. Okay? In other words, it doesn't matter which partial derivative you do first, it comes out the same. Okay? Well, if m is the partial of f with respect to x, our test to see whether the equation is exact is partial with respect to y of the m function has to equal the partial with respect to x of the n function. Because if the equation is exact, m is a partial of some unknown function with respect to x, n is the partial of that unknown function with respect to y. So that when we take the partial of m with respect to y, we're taking the partial of the partial of f with respect to, the partial of f with respect to x. So this would be like partial f with respect to x is your m function, partial with respect to y is your n function. Okay? I don't think I said that very well, but so this is just saying that if the equation is exact, this corresponds to this, and this corresponds to this. Okay? And there's your test. So if I write down just any old equation, like, let's just say x squared times cosine of y dx plus x sine of y dy equals 0. Okay, is this exact? Well, this x squared cosine of y would then have to be partial of f with respect to x for some function. Okay, and it certainly is. It's a partial with respect to x of 1/3 x cubed cosine y. Okay? We just take an antiderivative with respect to x. Treat the cosine of y as a constant. It's kind of foreshadowing what we're going to do to discover what f is. Okay? And x sine of y for the same f of x bar. Okay? Well, if you take an antiderivative of this with respect to y, you're going to get negative x cosine y instead of x cubed over 3 cosine y. Okay? So it isn't exact. Okay? Well, instead of trying to integrate these things with respect to x and with respect to y, we can use this test here. Okay? equivalently, partial of m, this would be your m function, this is 1 front of dx, right? Partial with respect to y is x cosine y. And that's the right thing to do, should have been partial of x with respect to y is negative x squared sine of y. And the partial of n with respect to x, this thing is just sine y, right? These are not equal. The result is that there's no such function f. Because if there was, this would just be the partial of f with respect, the partial with respect to y of the partial of f with respect to x. It would be this derivative, okay? And this would be this derivative. They'd have to be equal. Okay. So, let's move to problem in the text and let you see if you can apply the test. And if it is exact, then we'll see what you can do to recover the function.